Hi, this is Nurulan Adhinipohan, and today I'm gonna talk about a gold mining problem and how to solve it using linear programming and lingo. This problem was made by my team, which consists of me, Lutfi, and Rea. So let's just get to the problem, shall we? A gold mining firm produces gold in the form of necklaces, rings, and bars. Each necklace weighs 5 grams, while the ring weighs 1 gram and the gold bar weighs 10 grams. The production cost for the gold is 210,000 rupiah per gram, and the accessories has an additional labor cost that is 100,000 rupiah per gram. Each month, the firm has 500 workers and can at most produce 1,155 grams of gold. One necklace is made by 3 workers, a ring needs 2 workers, whereas a gold bar needs 1 worker. The selling price of each necklace is 470,000 rupiah per gram. For the ring is 470,000 rupiah per gram and 250,000 rupiah per gram for each gold bar. So each month, the demand for necklaces is 100 pieces, 50 pieces for the rings, and 25 pieces for the gold bars. The demand each month is considered constant. Formulate the given problem as a linear programming problem and find the solution using lingo or lendo. So, first of all, before we go in deciding on how to solve this, we should note the important details. Uh, we should note that the production cost for one gold is 210,000 rupiah per gram. There is an additional cost of 100,000 per gram for the accessories, that is the necklaces and the rings. Okay, so the first step is to find the total production cost of each item. So from the problem, we can see that 1 gram of gold cost 210,000 rupiah and the labor cost for 1 gram of gold is 100,000 rupiah. The weight of a necklace is 5 grams, the weight of a ring is 1 gram, and the weight of a gold bar is 10 grams. From this information, we can easily find out the total production cost of each item. So for example, for the necklace, it weighs 5 grams. So for the production cost of the gold, it will be 5 times 210,000 rupiah. In addition to it, because it is an accessory, 5 times 100,000 because of the labor cost. So that will total in 1,550,000 rupiah. For the ring, we do the same thing. 1 times 210,000 plus 1 times 100,000. For the gold bar, it's the same steps. But because the gold bar is not an accessory, you just multiply the weight of the gold bar, that is 10 grams, with the price of 1 gram of gold, that is 210,000. This will total in 2.1 million rupiah. So now that we figured that out, the next step is to find the selling cost. So from the problem, we can see that 1 gram of gold in a necklace is sold for 470,000 rupiah. 1 gram of gold in a ring is sold for 470,000 rupiah also, while 1 gram of gold in a gold bar is sold for 250,000 rupiah. So because we know these details, it'll be easy for us to find the total selling price of each item. So for example, for the gold necklaces, one necklace, as we know, weighs 5 grams. So by that logic, the total selling price of a necklace is 5 times 470,000 rupiah. So that will total to 2.35 million rupiah. For the ring is 470,000 rupiah, while for the gold bar is 2.5 million rupiah. So now that we have found out the total production cost and the selling cost, we can move on to the next step to solve this problem using lingo, that is declaring the variables. So in lingo, to formulate a problem, we need to first declare the variables so that the program can understand the parameters that is given to it. So in this case, the declaring variables for this problem is x1, that is the numbers of necklaces produced, x2, the numbers of rings produced, and x3, the number of gold bars produced. Next step is to find the objective function of the problem. For the objective function, we will first need to look back at the calculations we did. So here is a table summarizing it all. Well, the objective function that is needed from this problem is a formula that can maximize the firm's profit. So by that logic, we need to know the selling cost minus the production cost times the amount of item produced. So this will be the objective function. Max z equals 2.35 million minus 1.55 million times x1 plus 470,000 minus 310,000 times x2 plus 2.5 million minus 2.1 million times x3. Now, because this number is too big, let's simplify it by subtracting it all and dividing it by 1000 so that the number is more manageable. So this will result in max z equals 800x1 plus 160x2 plus 400x3. The next step is to define the constraints. This problem has 4 constraints. The first one is production constraint. So as we know from the problem, the firm can only produce 1,155 grams of gold each month. This amount will be divided into the 3 items that they produce: necklaces, rings, and gold bars. And because as we know one necklace weighs 5 grams, that means 5 will times how much necklaces they produce plus 1 gram for every ring they produce, and plus 10 grams times how many ever gold bars they produce should be less than or equals to 1,155 grams, because that is basically all of the gold this firm can produce. So the second constraint is the constraint of amount of workers. So the company, as we know, has only 500 workers each month. These 500 workers, let's assume they can only work at one item at a time. So the necklaces needs 3 workers. So this will be 3 times how many ever necklaces needed to be produced, 2 times how many rings needs to be produced, and plus just the amount of gold bars that needs to be produced. This total should be less than or equal to 500, because as we know, that's all the workers that the firm have. So the next one, which is the third, is the demand constraint. This demand constraint shows the minimum items that should be produced by the firm, because the demand for them each month is, as you can see, the necklace each month should be no less than 100, because from the problem we can see that each month 100 pieces of necklace is sold at minimum. So by that logic, also for the rings, the number of rings produced should not be less than 50, and the minimum number of gold bars produced should be no less than 25. So the last constraint is rather a constraint for the lingo programs. So it's a non-negativity constraint. This is just basically saying that x1, x2, x3 cannot be negative because there is no possible way that the numbers of necklaces, rings, or gold bars produced can be less than 0. So now that you have the objective function and the constraint variables, we can move on to making the lingo model. So this is what the lingo model should look like. It's basically the exact same thing, but adjusted to the lingo language. This part, general integer, or as you can see GIN and the variables, it will just basically mean the result cannot be in decimals because the production of each item can never be just part of it. It will be a whole item. So that's why we added general integer. Okay. This is the solution we got from Lingo. Now, as you can see, the objective value or the estimated amount of profit to be gained by the firm is 121,600. Mind you, we shouldn't forget that we divided the function by 1000. So, to make it back to normal, we should multiply this number by 1000. So it will be 121,600,000 rupiah in profit. The number of necklaces, which is x1, to be produced is 116. Numbers of rings produced is 50, while the number of gold bars to be produced is 52. So in conclusion, according to Lingo, to maximize the firm's profit, the company must produce 116 necklaces, 50 rings, and 52 gold bars. The maximum profit that can be achieved is 121,600,000 rupiah. This is the end of the video. Thank you so much for watching. Before I end this, my team and I would like to apologize for any mistakes we might have made or any shortcomings. So feel free to comment down below what you think or give us suggestions or criticisms. Basically anything you want. So yeah, that's it. Thank you and goodbye.